Hello Year 6, welcome to today's maths lesson. I'm not going to really talk too much about what it's about because I've got a question for you in a moment, so I don't want to spoil it. As usual, when I ask you a question, please don't be embarrassed about talking out loud. Okay, you should be getting used to it by now, I would have thought. Enjoy the maths. Okay, so can you tell me, what are we looking at here? What's going on? What are these deans here as they are? What do you notice about them? Yeah, that's right. They show the place value columns with amounts getting 10 times bigger each time. A 1, 10 ones make a 10, 10 tens make 100, 10 hundreds being 1,000, and 10 thousands making a 10,000. Someone said the difference between each amount is getting much bigger every time, and it's getting bigger and bigger as we add a new column. And that's true. 9 more than 1 is 10. 90 more than 10 is 100. 900 more than 100 is 1,000. 9,000 more than 1,000 is 10,000. Can you imagine what 100,000 might look like with deans? I'll be honest, I haven't got enough to show you, but can you picture it? Well, some people try and imagine that column of 10,000s growing and being 10 times taller. That's hard to imagine, it's hard to picture. Other people imagine 10 lots of 10,000 spreading across and filling that whole area. That's a lot of deans, isn't it? That's 100,000. So these numbers are really hard to imagine as they get bigger. So let's try and get a way of thinking about how big these numbers are. So let's think about seconds. If you could count one number for 1 second, how long would it take to count to 1? 1 second, that's easy. How long would it take to count to 10? Yeah, 10 seconds, it's still easy, isn't it? You can imagine doing that. How long would it take to count to 100? Yeah, 1 minute 40 seconds, that's 100 seconds, easy. 1,000? How long do you think that would take to count to? Yeah, 16 minutes and 40 seconds. It's getting a bit boring now, isn't it? It's going to take a lot of time. 10,000, how long would that take to count up to? Yeah, 2 3/4 hours. That's quite a long time. 100,000. That would take you 27 3/4 hours, more than a day without any sleep to count that far. How about 1 million? How long would it take you to count 1 million? And that's assuming you could name the number in 1 second. 11 days. You'd be counting for 11 days without sleep or rest at an incredible speed. That's a big number. People talk about billions. We're not going to worry about those today. That's the good news. But there are 7 billion people on Earth. And some people have billions of pounds. How long do you think it would take to count to 1 billion? Again, we're cheating a bit, thinking that we can name a number in 1 second. It's over 31 years. No sleep, no rest. 31 years. And if you were counting to 10 billion, it would take longer than a human lifetime. 310 years. These are numbers that are almost impossible to imagine. So, how do we write the number 1 million? What are the name of each column as we get 10 times bigger? We can see the 1 column. When we've got 10 ones, we group them into, tell me? Yeah, 110. When we get 10 ones, we group them into, yeah, 100 ones. Then when we get 100 ones, 100, we group 10 hundreds to make, yeah, 1000. 10 of those makes, yeah, 10,000. 10 of those makes, yeah, 100,000. 10 of those 100,000s make 1 million. 10 of those million makes 10 million. You don't need to worry about that at primary school. 10 of those makes 100 million. Right. What does this picture show? Yeah, it shows 100th getting 10 times bigger, 10 times bigger, 10 times bigger, and so on until it reaches a million. So I'm going to test you on that. If we start with 100th, tell me what number is 10 times bigger? Yep, 1/10. 10 times bigger than that? Yep. 10 times bigger? 10 times bigger? 10 times bigger again? 10 times bigger again? 10 times bigger again? 10 times bigger again? And 10 times bigger again? 10 times bigger again? Don't need to worry about it. It would have been 100 million then. Right. Can you tell me why I've got 3 colours here on my place value grid? That's right. There are 3 groups of digits that we name as a group. Here are how many millions we've got, some millions. Then we've got some thousands, some thousands. And then we've got the smaller bits, the easy bits, the bits we can name really easily. Can you read this number out to me, please? Yeah, 1,937. Let's have a look at another number. Remember, if we've got millions, we name them first, then we name how many thousands, then we name the rest. Read this number out. Yeah, 51,937. Another number. That's right, 451,937. Another number. That's right, we've got 3 parts to name, haven't we? We've got 5,451,000 and the easy bit, 937. There it is. Let's practice some more. Can you read this number out loud? Name it out loud, please. That's right, we named 1,000 parts first. There are no millions. 752,421. Don't forget to use the 3 parts to name that number if you need them. This number, can you name it out loud? Read it out, please. That was 3,02,421. Name this, please. 400,421, and this number. 5,050,421. This calculator shows a number with a lot of digits. It's a big number and it's very difficult to read. My friend says if you picture in your mind some commas being used to break the number into those three parts, it's much easier to name. Can you imagine them? Can you picture where those commas are? And can you then read the number out loud, please? Well, in my imagination, I saw the ones, the tens, the hundreds. I saw three digits and I knew I needed a comma to show that these were, thousands. And then I knew these next three digits, thousands, 10,000s, hundreds of thousands. I know when we've got 10 hundred thousands, we get a million. So I counted three digits, imagined a comma here, and I knew these were millions. 2,569,241. Some of these numbers have used commas in a helpful way. They've been written correctly. They help us read the number. Some have used commas in a confusing way, in a wrong way. They don't show us where the thousands or the millions are, and it gets tricky. So are they written correctly or incorrectly? Have a look at this number. Tell me whether it's correct or incorrect, and read the number out loud to me, please. Yeah, I thought it was correctly written. The decimal point means that this are the ones, this column are tens, hundreds, thousands. 6,439.1. Let's have a look at this number. Is the comma correct? Is it not? Can you read the number to me? It's definitely correct. Three digits, ones, tens, hundreds, so these are thousands. 762,148. This number, correct or incorrect? Name it. Well, I saw three digits, these must be thousands. These three digits are all thousands, and these must be millions. 4,826,591. How about this? Correct or incorrect? What is the number? Oh, it's incorrect, isn't it? One digit, two digit, this must be, it's the hundreds, it's not thousands. So the 8 must be in the thousands. We've got 18,572. Not helpful, that comma. Let's have a read of this. Is this correct or incorrect? Yeah, it's incorrect, isn't it? The decimal point tells me this must be ones. If they're ones, tens, hundreds. So these must be thousands. So this is 7,361.8. Here's a number made out of place value counters. Can you think of these counters in the groups? Millions, thousands, the easy bits? And can you name this number for me? Well, looking for millions, I've got 1 million. Thousands, these are all made of thousands. We've got 200, 10, and 5, 215 thousands. And the rest of it is 732. Similar again, there's a bit of a trick here, see if you can spot it. What is the name of this number? Well, the millions are easy bit, aren't they? 3 million. Thousands are tricky. There's 100 and 1, 2, 3, 103,000. And we've got 652, 3,103,652. Here are some parts of a number. If you put them all together, what number do we make? Name the amount that's highlighted by the stars. Put them together and tell me what number we get. Well, we get 6 million. Thousands, we get 265. 6,265,973. I'm going to show you a number with blank number discs. Read the name of the number for me. Yeah, 1,110,000. Here's a number, read it out loud for me. Right, so I'm wondering what the digits are worth. What do the digits stand for? What is their value? What is that 5 worth? Can you find it on here? 5 stands for, the 5 has a value of 5 million. The digit 3 is worth how much? Find it on here again. $300,000. The digit 8 has a value of 80,000. The digit 1 has a value of 1,000. The digit 4 has a value of 400. The 9 has a value of 90. And finally the 2 is worth 2. So that's, again, what's the 5 worth? 5 million. The 3 is 300,000. The next part, 80,000. 1,000 plus 400 plus 90 plus 2. Can you name this number? Well, we've got 1 million. What have we got here? 200,000. What have we got here? 30,000. What have we got here? 6,000. What have we got here? 10. Put them all together and name it, please. $1,236,010. put all the like pieces together and tell me what number we have here, please. So we have 200,000, we have 10,000, we have 100, and we have 20, and that makes 210,120. Name this number for me, please. It's 2,314,523. What would the number become if we added 30,000? Can you picture that happening here with the PV counters? And can you tell me what the number will be? What will the total of these two amounts be? What will that number become? Yeah, well, I pictured another 3 10,000s coming here. So I could see that that one 10,000 would become 4. So I've got 2,344,523. I've got some statements here about this number. Some are true, some are false. Let's see what you think. First quote. If I added another 100, my number would have 5 loose hundreds in it. Of course, experts know that all the bigger parts are made of hundreds, but my number would have 5 loose hundreds in it. Is that true? Is this the 100 column, I wonder? No, of course it's not. That's the 1,000 column. There are 8 loose thousands that haven't been grouped. 8 loose hundreds, rather, that haven't been grouped. One more 100 would make 900. Next statement. My number has 600 thousands. Does it? No, of course it doesn't. It has 6 10,000s. There are 7 100,000s. The digit 7 is in the 100,000 column. Next statement. The value of the digit 4 is 1,000. True or false? Well, I think it is in the 1,000 column, but the 4 will have a value of 4 of those. So it has a value of 4,000. That's not true. The value of the digit 1 is 10. Here it is. Yeah, it's in the 10 column. It's 110. It's worth 10. The number is nearer 2 million than 3 million. Is that true or false? Well, it has more than 500,000. 700,000 is nearer the next million. So I think it's nearer 3 million. It's false. Excellent. Now, have a go at some of the worksheets that come with this video. Thanks for that, Year 6. So hopefully now you can name and partition crazy big numbers up to 10 million. If you want to know what a million looks like, as we know, it's really, really hard. But you might want to watch another video that we're doing about how a million is composed. There's something interesting to watch there. Anyway, see you soon.